All right, so we were looking earlier in the week at concurrency and wait groups, and I don't think I recorded that in here. That would have been good to record. That's a bummer. I kind of dropped off on the recording for a couple of days because we had turbulent material, meaning the flow of the class wasn't such that it lent itself well to a recording. All right, but now we're going to look at wait groups. And I don't want to look at the question because this is confusing enough and new enough. I don't want to confuse you. I just want to look at the answer, and we'll analyze the answer. So take a look at this code. And what do you think?
I mean, print C. C.
Yeah, well, that
no,
print C.
Anything because A is 0. So.
Will that print C?
There is no string 3.
Oh.
It'll give it an error, right?
Oh, I get it. Okay.
Out of range here.
Runtime error. Index out of range. 0, 1, 2. What would be if we'd done 2?
Then it would print C.
99.
99.
Because that is
The 99.
Oh, is that the 99 room?
ASCII wiki. $99 C is decimal 99. Decimal 99 C. All right, so what's this rest of this stuff do? Defer, so it's functional run last. It's going to self-execute. If there's an error, recover. Right, so when we run recover, if there's an error, error is not nil, restored, and it'll print the error. Okay, so restore 99.
Okay, but go back to make it 3 again.
Thank you. Restored, runtime error, index out of range. So the program is kind of like it recovers, right? So instead of the program dying, it recovers from the error. That's kind of interesting. Like, I didn't teach you guys any error stuff in here because I'm still learning it myself. And errors are kind of in Go is like check them when they happen. I've never really liked the try-catch thing. Let me just see a show of hands. Like, how many people like try-catch? Like, I just like that.
It's just, I mean, it works. I'm not going to say I like it or I dislike it, but it works.
Well, this seems a lot simpler, though.
Like, when do you use it, though?
When do you seem easier.
When do you use try-catch? Like, on everything? Let me try this now and try that. Like, or how do you determine, like, well, this is a little risky. I should probably do try-catch. Like, opening a file, that file might not be there. Let me do try-catch.
If you're going to be, like, really, what's the word? If you're going to polish your program for users to use, then, like, everything has to have try-catch in it, yeah.
Yeah.
Because just everything every single thing that could possibly go wrong has to be handled.
Yeah, you gotta handle the exceptions or you're not a pro programmer.
Yeah, you got to handle the exceptions, right?
But it always bugged me in Java doing that.
I've never liked try-catch. I don't want to try and then catch.
And then
Yeah.
I just want to write my code and it's going to work.
Yeah.
You know?
Then you gotta make sure you define your variables outside of the try so that you can use them outside of it in case this goes.
Pain in the butt.
It's a lot of writing.
Yeah. So anyhow, this is a way you could do catch and go, and that's the defer function. But mostly the way, and I've been reading about error handling in Go recently because I need to add that into my Udemy course, right? But mostly error handling in Go is that thing where we do if error is not nil, like we try something and we return an error and then we just check the error, and so that's how we do Go handling or error in Go. All right, so. Now we've got that same thing here with that defer recover, right? And then here's WG done. So wait group. So here's the wait group. And then there we're kind of doing that thing. And then in func main, we're looping and we're adding 1 to the wait group. So the wait group was defined up here. Add 1 to it. and then we're going and we're going to do this, and it's going to go, 0 times, 1 time. That's it. It's kind of a pointless loop. And then we wait, and so we wait for that to finish, and when it finishes, it does done, and then we hit print line. Is this code okay? We're learning about using wait groups. Is this the right place to call WG done?
I thought you should put that at the end. I thought you should put that at the end of the function or something. Or no, after all. It doesn't look right. Not in the
No,
middle.
it's outside of the loop, and the loop includes go do, and the wait group is inside of do.
Yeah, that doesn't seem right to me, because if this runs successfully, we didn't call done. This only runs, right? Defer func. No, that runs. This runs if there's an error, and that will always run. So that's fine, because
It's after the
defer, and then this function executes at the end of this function, and then this will run if there's an error, and then that runs, and we're out. So that will take one away,
So
and then the wait.
Wait comes after done.
Yeah, wait comes down here. Right, so this is where we send off that
Wait
concurrent
is
process.
wait until all the group is empty.
Wait until this has gone back to 0. So we get the wait group,
Okay.
we add 1 to it here, then this all runs. Well, this runs, and then this runs, and we take 1 away, and then that goes back to 0. So it's waiting till this goes 0. When it goes to 0, it does that. Wah, wah, wah. I just checked my imports there to have my imports automatically, be added. When I hit format, you saw it add in sync, and then I could run it. Index out of range. This line should be printed after all those invocations fail. I could crank this up. Right, just kept running, catching it, recovering, and then here. It's kind of interesting.
Why is it here?
Oh, because we're accessing 3, index out of range.
Oh, there. Okay.
We could do this.
So you're just running it 7 times.
Yeah, or this might be fun. So go do. What happens if we pass in I? And then right here, this will take, I don't know, take another thing. It'll take in, which is an int. I just want to give it a different name identifier, and then we come down here and we'll pass in n. Runtime error, index out of range. And then we got 979899 runtime error. That's kind of interesting. This line should be printed at the end. Huh. How did we get 979? Oh, 97, 98, 99. Right? Let me do this. Oh, this will be easier right here. Print line. There we go. That makes sense, right? Because when it's 0, we get that. And what is A? A is 97, right? B is 98. C is 99. So we got 97, 98, 99. Is there a problem with this code?
Yeah, that goes too high. You can put i.e. less than length of str.
I goes too high. Yeah, and we could do some catch here, but one of the main problems here with concurrency is this right here.
Okay, so can you, because go do, because the str variable is inside of do, you can't use it in the loop, can you? You can't define I as based on the length of str.
Let's print out n.
Because str is, you don't have the scope for that, right?
We're gonna run it again.
Do you know what I'm saying?
And I don't have the scope for which one?
I is less than, you can't define, instead of 7, the length of str because...
Yeah, no, the scope of str is from here to there. It's there from there to there.
Yeah, it's inside the do function.
Yeah.
So...
I could do a conditional logic right here around this, right? I could say if n is less than length str. So length of str is 3, so 0, 1, 2, right? And in which case, do that. Right? That's one way to do it. No errors that time. That makes sense? Because the scope of str is from there to there, so I could use it right here.
I was wondering.
So how did that stop?
Because when n comes through and it's not 0, 1, or 2, it's less than 3, right?
Yeah.
So when n is 0, 1, or 2, cool, we can access 0, 1, or 2.
Then does it even... So why didn't it run it 7 times?
It did run it 7 times.
It stopped. I mean, it didn't print.
I could do this.
It ran it and it just didn't print anything.
I could do format print in with a tab, right?
Okay, so it only printed it when it was... Okay.
That's funny. And then here's, where do we want the new line? That's kind of weird. I'm just going to comment this out for a second. 6, 0, 1, 2, 3, 4, 5 is the order that printed.
Okay.
6, 0, 1, 2, 3, 4, 5. So that's interesting. So let's get rid of all this. I want to go back to the other problem. That was definitely one of the things you could think about.
So it loops around 7 times, but it only prints when there's a corresponding value to the string. Oh, now it's giving errors.
Yeah, because I took away that check. And
So I was wondering.
and those give me errors. So let me do this into 2 lines.
I was wondering how to write the loop so that it accesses the string, the length of the string.
Oh, that was the way to do it with the conditional logic check.
That makes sense.
All right, let's run
Doesn't
that.
stop it from looping around extra times.
Okay.
Not necessary extra times.
So this is n. So I gets passed in, and it comes in right here, and then we say print n, and we get 6, 0, 1, 2, 3, 4, 5. So it's interesting that the last one happens first, right?
Yeah, well,
And 0, 1, 2. Well, the problem with this is if we were to run a race condition check on this, and I can't do that right here, but if I take this over to WebStorm, and I guess let's do it right here. And then I have concurrency, go routines, and go concurrency. Where did I check race conditions? I don't know, man. I don't know what I want to add in there. Keep that
Saw it.
pristine. Oh, you saw something
Yeah.
in there about race conditions? Oh, race condition. And so I could add a new O1. And then I could do copy the O2. And then let's add in a little bit of a note here. And let's call it a README. And this is to illustrate checking a race condition. Use go run dash race main.go at terminal. And so we'll add in here this code. I don't know if we need this file in here because I got one and the other one. And this is kind of just complicates it. All right, so watch what happens when I run this. I'm going to take this out and just put it back the way it was. So I need to go to terminal and change directories, documents, go, source, GitHub goes to 11, and Golang training, and 22, and 06, and 02. Go run dash race main.go. It's going to blow up. What? Runtime error, index out of range. This line should be printed after all those. Index out of range, index out of range. I thought that would. Well, that'd be a race condition. No problems. I guess there's no problem there. Never mind. I was thinking right here, you have to do go func I still think this is the more correct way to do it. And then here you'd pass in I. So that, by doing that, I'm no longer relying on this scope, which, you know, that's going to be racing through iterations, right? So I'm taking that and I'm passing it into this function, and then that scope becomes this, and it's taking k with it. And every iteration that's going to change, but that is sealed as I send that off. You're taking that number with you. So that's the way I've seen it done. I don't know why that didn't blow up as a race condition. Let's see something blow up as a race condition. So we'll get rid of this file, get rid of this file, get rid of this folder. And let's check this one. Incrementer foo and bar. And we have incrementer, oh, okay, incrementer, string, and it's looping. And then x plus plus, x is equal to counter. And then there are that, and then we have add to and wait and done. And they're both accessing count. They're both accessing counter. So here's the variable counter. Okay. And we're going to launch two Go routines. So we're going to say, hey, add 2 to my wait group, and then it's going to wait. And then each Go routine is launching the same function. They're both launching incrementer. And when each of those get done doing their loops, right, they're going to say I'm done. And so when done goes to 0, this wait will finish, and we'll print out the counter value. And so we do go incrementer. We pass in a string foo, and we use that right here just to print out, hey, is it coming from foo or from bar? So then we have x is equal to the counter. So whatever the counter value is right now, we're setting that equal to x, and then we're adding 1 to it. And then we're saying that the counter is now equal to x. So that's convoluted. I could have just done counter plus plus, but what I wanted to illustrate with this file was this. GitHub.com, Arden Labs, Go Training, race. I wanted to illustrate this. So basically here we have one function running on this side. We have one function running on this side. We have a global variable which they're both sharing. This function pulls the value of it. This function pulls the value of it. This function increments it, writes the value back to the global variable. This function increments it, writes the value back to the global variable. At this point it should be 2 if we're truly keeping track of every time it's been incremented. But it's only 1 because you can see here they pull it, they increment it, they write it back. They both pulled it at 0, added 1 to it, wrote back 1. So that's a race condition. We have 2 processes accessing a shared variable, and they haven't synced or coordinated their work. So when I run the race condition on this one, go build race main.go. What? Found one data race. And there's all the information about it. Data race. And it's saying, hey, go routine 6, go routine 7 at line 26, 26, 15, 16. So line 26, 26, 15, 16. Those are the culprits. All right, so all of that was because we started looking at this and go do, and then a slightly different way to do it. So I kind of think this is an interesting one to compare these two. So here in this one, wait group, do, wait group add, wait group done. And then here in this one, there's the wait group, but now this is taking a pointer to the wait group. Instead of up here, wait group was outside. So here we do var g sync wait group inside main instead of outside main. So inside main, and then we pass to it the wait group. We add one, we pass the wait group, and then the wait group comes in and we say wait group done. It's kind of an interesting way to do it. All right, so I don't know what I'd call that video. What did you learn in 23 minutes? What would you call that video?
Racing.
Race conditions? Is that the main thing? Concurrency and race conditions. And wait groups. I think wait groups is a good one there too. All right, stop.